This is Dr. Zooxanthella with Prime Coral, and tonight we're going to play a little game called the guessing game. So what I have here is a coral that has turned brown over several months. No polyp extension, stopped growing. If you look at the base, the encrustation, it stopped, receded a little bit, about 2 or 3 millimeters. Very common, very dark coral. And well, let's see what we find in the water that it's sitting in. So pour a little bit of water into a petri dish. To me, when I look at this water, it looks crystal clear. There's really nothing. I can't see anything in there. Looks pretty innocuous to me. So we're going to go ahead and set it onto the microscope stage. We're going to use a 40x magnification. And wow, that water looked totally normal to me, but I know the coral is kind of STN from the history. And here's what we have. You can see the water is chock full of philasters and euplotes. Euplotes are the egg-shaped protozoans. These are single-cell organisms. They've been described by marine biologists as being associated with coral tissue loss, but nobody's ever definitively identified them as the cause of coral tissue loss until I performed my set of experiments last year in 2018, back in June, July, August, and I proved that coral rapid tissue necrosis was caused by philaster. This is a philaster here. Also, what you're seeing streaking around in the water are philasters primarily. They will land on the bottom of the petri dish, but these large ones that look like a huge vacuum mouth, those are euplotes. And it doesn't surprise me to find lots of euplotes because this coral apparently has been dying over a long time. Here's a piece of coral tissue. This is nice. You can actually see a little buffet going on between philaster and euplotes eating the coral tissue. If you look carefully, you'll see little dots. Those are Zooxanthella within the coral tissue. And some people think that these are just scavengers that smell a dead coral and come and eat the dead tissue, but that's absolutely not the case. And the way you prove that is you take a normal coral that's healthy, you introduce just purified philaster into the water where the coral is, change no other parameters, and that coral will become infected with the philaster and it will RTN. Then you can isolate the philaster out of the RTN coral, and you can see that it's the same organism that you introduced that caused the RTN of the coral. So that's one of the components of Koch's postulates to prove a causal relationship between a microorganism and a disease. The disease being coral tissue necrosis. Here we have two microorganisms. We have the euplotes, which are big, they look like ladybugs, and then you got the skinny, fast-moving philasters that swim like Michael Phelps. Michael, please don't take offense. But these are the two primary organisms that cause, I believe, about 99% of all tissue necrosis within coral. I'm not talking just about SPS. Everyone seems to think this is an SPS disease. It just affects SPS more often because there are more polyps, so there are more entry points into the coral's gastrovascular cavity, which is what these organisms infect. They live in the intestinal system, basically, of the coral, and they eat the tissue and eventually starve the coral and kill it. And this has become an epidemic in the ocean, in the reefs, as well as in our aquariums at home. So these are the culprits you're watching here. Nice little video of them. Again, euplotes and philaster eating coral tissue. And again, the cause of coral tissue necrosis. I'm Dr. Zooxanthella from Prime Coral Labs.